Created by the hottest, most violent, and most energetic objects and events in the universe, gamma rays travel across vast stretches of space, only to be absorbed by Earth's atmosphere. Scientists had no way to detect and study gamma rays from the cosmos until high-altitude balloons and rockets carried gamma ray sensors above the atmosphere. Deadly to humans, gamma rays are created on Earth by natural radioactive decay, by nuclear explosions, and even by the lightning in thunderstorms. Coronal mass ejections from our Sun emit gamma rays, followed by masses of charged particles. Monitoring these gamma rays provides scientists with an early warning of incoming charged particles that may cause disruptions in power and communication networks. The most energetic of all EM waves, gamma rays carry enough energy to kill living cells. Doctors are able to selectively use gamma radiation to destroy cancer growths. Gamma ray wavelengths are the shortest of all electromagnetic waves, about the size of an atom's nucleus. In fact, it is so short that the rays sail through atoms as easily as comets sail through our solar system. This makes detecting gamma rays difficult for scientists. Gamma ray detectors typically contain densely packed crystal blocks. As gamma rays pass through, they collide with electrons in the crystal. The sensor doesn't directly detect gamma rays. Rather, it detects the charged particles created by those collisions. Scientists have used gamma rays to determine the elements that make up Martian surface soils. When struck by cosmic rays, chemical elements in soils and rocks emit uniquely identifiable signatures of energy in the form of gamma rays. The Gamma Ray Spectrometer on NASA's Mars Odyssey orbiter detects and maps these signatures, such as this map of hydrogen concentrations. Gamma rays stream from stars, supernovas, black holes, and pulsars to wash our sky with gamma ray light. NASA's Fermi Gamma Ray Space Telescope imaged the location of these sources, mapping out the Milky Way galaxy by creating a full 360-degree view of the galaxy from our perspective here on Earth. While the visible light sky is predictable and follows regular patterns, the gamma ray sky does not. Bursts of high-energy gamma radiation arrive from deep space every day. These explosions of gamma rays last fractions of a second to minutes, popping like cosmic flashbulbs, momentarily dominating the gamma ray sky and then fading. This video of the Vela pulsar beams gamma rays every 89 seconds as it rotates. Gamma ray bursts are the most energetic and luminous electromagnetic events since the Big Bang and can release more energy in 10 seconds than our Sun will emit in its entire 10 billion year expected lifetime. NASA's SWIFT satellite recorded this gamma ray burst of an exploding star 13 billion light-years away. It is among the most distant objects ever detected when the universe was just 630 million years old. A recent observation of a gamma ray burst produced the greatest total energy to date, equivalent to 9,000 typical supernovae. By continuing to study gamma rays, we will unlock important new understanding in astronomy, its use in medical treatments, and allow us to further enhance our protection for our satellites and other electronics here on Earth.
How are gamma rays used in everyday life? Because gamma rays can kill living cells, they are used to kill cancer cells without having to resort to difficult surgery. This is called radiotherapy, and works because healthy cells can repair themselves fairly when damaged by gamma rays, but cancer cells can't.
So I guess from that video you already have a background regarding to gamma rays. But to help you broaden your knowledge more about this topic, we will be discussing gamma rays, so hope you listen. Gamma radiation is electromagnetic radiation that is emitted by an unstable nucleus of an atom during the radioactive decay. A nucleus in an unstable state may fall to a more stable state by the emission of energy as gamma radiation. The radiation has a dual nature, that of a wave and a particle with zero mass at rest. It was Albert Einstein who first demonstrated the dual nature of electromagnetic radiation when he explained the photoelectric effect. He thus discovered the elementary particle known as the photon, which is electromagnetic radiation with its particulate nature. In addition to this, actually, ang kaning gamma rays kay it is the highest energy form of life. There is light now we can see in our eyes, but there are a lot of other types of light actually. It is also the most energetic form of life, in which it is the most powerful and dangerous at the same time. Ang gamma rays, they're the shortest in wavelength and the highest in frequency. So, mao na siya. And they can pass through the empty space within an atom.
Sources of gamma radiation. Natural sources of gamma rays on Earth include gamma decay from naturally occurring radioisotopes such as potassium-40, and also as a secondary radiation from various atmospheric interactions with cosmic ray particles. Some rare terrestrial natural sources that produce gamma rays that are not of a nuclear origin are lightning strikes and terrestrial gamma ray flashes, which produce high energy emissions from natural high energy voltages. So, from the first natural source of gamma rays on Earth, which is potassium-40. What is potassium-40? Potassium-40 is a radioactive isotope of potassium which has a long half-life of 1.25 billion years. It makes up about 0.012% of the total amount of potassium found in nature. Potassium-40 undergoes three types of radioactive decay. In terms of atomic weight, it is located between two more stable and far more abundant isotopes, potassium-39 and potassium-41, that make up 93.25% and 6.73% of the Earth's total potassium supply respectively. With a half-life of 1,251 billion years, potassium-40 existed in the remnants of dead stars whose agglomeration has led to the solar system with its planets. Potassium-40 has the unusual property of decaying into two different nuclei. In 89% of cases, beta-negative decay will lead to calcium-40, while 11% of the time argon-40 will be formed by electron captured.
Properties of gamma rays. As previously mentioned, gamma radiation is high-energy electromagnetic radiation. Its extremely short wavelength or high frequencies allow it to interact with matter at the atomic level. In addition, this causes gamma radiation to have high penetration power when compared to other forms of electromagnetic radiation or accelerated particles. Gamma radiation can only be shielded against with extremely dense and thick materials such as lead or concrete. This is in contrast to other forms of radiation such as alpha particles and beta particles, which are not made up of photons or oscillations in electromagnetic field, but instead are comprised with particles of matter. The difference between alpha, beta, and gamma rays. Gamma rays are neutral, while alpha particles have a positive charge and beta particles have a negative charge. Two protons and two neutrons are bound together to form an alpha particle. High-energy electrons are known as beta particles. Gamma rays are photons, which are electromagnetic energy waves.
What are gamma rays and what are they used for? Gamma rays are a form of high-energy electromagnetic radiation or oscillating photons. Gamma rays are used to observe and study the universe beyond Earth, are used in PET scans, and are employed as a means to target and kill cancer cells without surgery. Moreover, gamma rays are ionizing electromagnetic radiation obtained by the decay of an atomic nucleus. Gamma rays are more penetrating in matter and can damage living cells to a great extent. Gamma rays are use in medicine or radiotherapy industry or sterilization and disinfection and the nuclear industry.
What everyday objects use gamma rays? Within the medical sciences, gamma radiation is used to treat cancer patients. PET scans can also emit gamma rays. Thunderstorms on Earth also produce enough energy to emit high-energy gamma photons.
What are three uses for gamma rays? Gamma radiation from cosmic system, detected, measured, and studied by astronomers. Gamma radiation within the medical science is used within PET scans and as a means to treat cancer patients through targeting and killing tumors with gamma rays. And also gamma rays is used in medicine, radiotherapy industry, sterilization and disinfection, and the nuclear industry. Shielding against gamma rays is essential because they can cause disease to skin or blood eye disorders and cancers.
In conclusion, gamma rays have good effects and bad effects on nature. The dangers of gamma rays are not easy to deal with. With exposure to gamma rays, you can be easily affected with the risk of mutations or cancer in tissue. The use of it have revolutionized radiation therapy.